So we have the properties of the limits. Most of them are pretty obvious. For example, when it says sum or difference, do I see plus or minus? When it says product, f of x is being multiplied by g of x. So we know that one. So I want to mainly focus on A and F, because this may be one where you might need a reminder or maybe a little bit new. So on here, when I have f of x stuck with some value, that value can be put outside of the limit, meaning it can be rewritten as b times a whole limit as x approaches to c of f of x. Right now it sounds kind of awkward because there's no number. We'll get to once with the examples with numbers. Now looking at f. Do I see my f, or these are composition of functions, meaning we have a function within a function. In that case, you bring the outside function, or the very, very outside next to it, in front. So we have f of the limit as x approaches c of g of x. And these were functions within a function. So I want to look at example number 1. And I want you to box off this whole chunk of the limit and the other. Anytime I see this whole chunk, I can plug in the 9. When I see the next chunk of g of x, I can plug in the negative 2. So let's see what that basically means on part A. What number can I pull out? The 4. So when I take the 4 out, we get 4 times, let me put this in bracket, limit as x approaches to c of f of x. And then I want you to notice something. Isn't all that what I have boxed on number 1? So all that is representing what number? 9. So 4 times 9. What is 4 times 9? 36. Since the AP test has free response, meaning open-ended, and multiple choice, if it were to be a multiple choice, it'll be simplified all the way. For free response, all you have to do is plug things in, and you stop right there. So if you get a brain fart and you go, I don't know 4 times 9, leave it for all the free responses. Okay? So let's move on to part B. What operation is separating the two functions on this one? Addition. So let's rewrite this. Limit as x approaches to c of f of x plus the limit of x approaching c of g of x. And we know the whole chunk represented on the left and the right is 9 and negative 2. So we're plugging in 9 plus a negative 2. How many? 7. And again, if it's multiple choice, you go all the way to the simplified form. If it is free response, plug it in and you're good to go. Are we good on that one? It sounds like today's all about substitution, right? So on the third one, what is annoying about the third one? What is intimidating?
You got a negative exponent.
There's a negative, there's an exponent, there's a fraction. So let's see how we should go about this problem. First, I see this whole chunk that is representing 9. Do we all see that? So let's write out 9 to the power of negative 3 over 2. Let's do a recap on some of the rules of the power rules from last year or even in Algebra 2. When you have a power that is a negative, how do I make that a positive? Put it at the bottom, and it becomes positive, and we have the understood one. And then I can write this in 2 different forms. I can choose to cube the 9 first, or square root the 9 first. Which is easier? You want to cube the 9? I'm done at 81. Don't tell me to multiply by 9 again. I'm going to square root it. So here's how I'm going to write it. I want to square root the 9 first, and then cube it. What is square root of 9?
3.
And 3 to the power of 3 is? 27. So where do you guys think we can stop for the free response part? Here, here, or here?
Number 2.
The first one. You stop right here. If you're like, hey, I don't like that negative, don't even worry about it. That's a nice thing about the free response. So on number 2, this one is actually approaching a number. How many equations do we have on this one? Ooh,
No.
we have 2. Let's go ahead and rewrite this with our rule f on this one. I'm going to take out the very last function, f, and then write out the limit in the inside. Notice my limit is reaching 3 of g of x. So my main focus is, I need to plug in 3 into my g function. My g function is my second one. So we have 5 times a 3 minus 10. How many is that? 5. Are we done? That was only for the g. So now I need f of 5. So we're plugging in 5 into our f of x function, which happens to be 3 times 25. Plug it in as you go if you're comfortable. Minus 10 plus 5. How many is 3 times 25? And then I'm going to add the 5 first and minus 10. How many is that? 70. Boom, done. So now let's see the limit as it is approaching on a graph then. So this part will be no new information, right? Should I rewrite this function? I want to move the sign to the outside. So we have sine of the whole chunk, limit as x approaches the 1 of the f of x. And I want you to notice the graph is the f of x. So we're not plugging this into any of the equation. What number is it approaching? When it is approaching, it's approaching along the line. So from the left and from the right, it is approaching what value? Okay, so that 3 was just for the inside piece. Leave the sign on the outside. And I want to talk about this value right here. What is this thing called? It is called a point. And a point is denoted by x comma y, in this case 1 comma 2. Yes, it's just a distractor. Okay? So sine of 3. Can we evaluate sine of 3 without a calculator? Can you evaluate sine of 30 degrees?
Yeah.
What is sine of 30 degrees? 1 over 2. So if it is doable, then solve for it. But in this case, without a calculator, we can't. Oh, why did I put equal to? So I'm going to be okay with that. So unless it's one of the special rights, you do not have to compute. Leave it as it is. Are we all good? Okay. What should I pull out on number 4? The natural log. Anyone still in the habit of saying ln? Natural log is the formal way. And then let's put in the limit in the inside. This time it is approaching what value? 2. So let's go ahead and look at our graph. It is approaching again on the line. So on the line, it is approaching what number if it is common? It's also approaching 2. And the natural log we didn't do anything about. Can you compute natural log of 2? No. What if I say natural log of 1? Can you compute that? What is natural log of 1? What is it? 0. Let's move on. If that was confusing, that's okay. I'll give you all more reminders. Okay, let's go to number 5. Number 5 and 6 is from 1.2. So 5 and 6 is from 1.2 notes. So I'm going to do a recap in case you forgot. Give me 2 bullet points. When you plug something in and you get 0 over 0, what do we do? Factor, we do more. And what if you get some value over 0? What does that give us? Undefined. It is undefined. So does the limit exist? We're going to write out what? Does not exist. If someone said factor on the first bullet point, so I'm going to write that out. Thank you. And it does not exist when it's divided by 0 for the following reason: vertical asymptote, which is the unbounded behavior. This is strictly review from the last lesson. So let's do example 5 and 6 with the neighbor. Tap on your neighbor. Just say, hey, remind me, I forgot.
Oh yeah, you're right.
Well, I plugged it in, that was what I did. Just 5 squared is 25 plus 10 minus 2. So that's where I got 35 minus 2. And I worked over there, I forgot. You know, just.
Did you get on the quiz?
I didn't get that.
Okay, so apparently the graphs where there's like a open circle, apparently that's understood. I got those wrong.
When it's an open circle and you're looking for F of the number,
Yeah.
then you pick the one that's pulled up. And then
Pick the one that's
then you pick the pulled up. If there's
Oh,
no,
you picked the full.
yeah, that's looking for the actual value that's still being.
Oh, I see. So you
Yeah.
don't pick that. That was my problem. I got
Yeah.
two of those wrong.
And then
Yeah.
you take the whatever out.
You go ahead and finish this now. I like how it's bled through in gold.
Two.
45. Yeah.
Okay, I forgot. How do you do the divide with the thing in the bottom? I multiply it by itself and that gives me 1. Right, but I'm dividing and then I flip it because this is the division, so it would be 3, 2 over this, over 2, 2, and then for the 3.
All right, let's go over number 5. The first thing we need to do is what? Plug it in. And when I plugged it in, did y'all get 0 over 0? So therefore, we must do more. Is it factorable on the top? Yep. Should I carry my limit symbol with me? Yes, until I plug it in. So what was factored out on the top? X minus 5, x plus 2. The bottom is good as it is. What eliminated? Boom. And once I do, can I then plug it in? So when I plug in the 5 into the remaining x, I get 5 plus 2, which is 7, and we're good to go. Everyone good with that? So always first plug it in, because it could exist without doing more. On number 6, when you plugged it in, it was 27 over 0. So what is it? Undefined meaning? Does not exist. Do not enter. All right, moving on. Let's step it up a little bit. And I want you guys to write something on this one. This one is going to be 0 over 0, and it's not going to be factored on this one. So I'm going to write on for these two, clever form of 1. And we'll see what that basically means. So on number 7, which part is uglier, top or the bottom?
Top.
Okay. Within the top, what part is ugly? The bottom of the top, right? So what you then need to do is, whichever one is ugly, you're going to take that and multiply by both of them. So in this case, 5 and 5 plus x. And if you struggled on this last year, let's perfect it this year.
And bottom?
And the bottom.
Okay.
And the reason I'm calling this clever form of 1 is, when I am multiplying something by the same number on the top and the bottom, aren't same numbers basically 1?
That's correct.
So that will be a clever form of 1. So let's apply this. We're taking all of this chunk and multiplying into my first fraction and second fraction. And actually, I forgot to plug it in, right? This ends up being 0 over 0,
No, wait, what? Oh, yeah, okay.
which means we do more in a different manner other than factor. That was my boo-boo. All right, so then, when I take this whole chunk and multiply by this, do you see 5 plus x is on the top and the bottom? They cancel. So then 5 times 1 is going to be 5. So let's write the limit notation. So I have my 5 minus. When all that chunk goes into my second one, I have 5 on the top and the bottom. That eliminates. But 5 plus x does not eliminate. Must be in parentheses since our negative in front means distribution. On the bottom, I will leave it alone. If you want to multiply it out, you can, but that might make your life a little bit difficult, so I would do what I'm doing. Okay, let's see if we can simplify the top. On my top, do I have a 0 pair?
What?
5 minus 5 is 0. So then I'm going to write out limit as x approaches 0. I just have the negative and the x. I like parentheses, so I'm going to use it quite often. The bottom, let's leave it as it is. And something nice will happen. As long as you have things multiply side by side, we are allowed to eliminate identical piece on the top and the bottom. What can I eliminate?
X.
The x's. So let's write out what's remaining. We have the limit as x approaches 0. Negative 1 all over, 5 times 5 plus x. Now let's plug in the 0 into the remaining x. I have negative 1 over 5 times 5 plus 0. That's going to give us negative 1 over 25. So limit does exist. The way it will be listed on your quiz will be the following. I will say in quotes, fractional value. And I typically like to write only at the end for some reason, but fractional value. Y'all have the equatio automatically embedded on your Google Forms, right?
Yes.
I don't use that. So instead, when you're typing this answer, put it sideways like this. So it'll mark it correct. Again, the equatio on there, I do not use. All right, so let's see the other clever form of 0, and I'm going to do some side note on the bottom, dealing with Algebra 1 and maybe Algebra 2 concept. So on the very bottom, I want you to give me like a little 2 bullet points. And let's analyze number 8 first. What do we not like about this problem? There's a square root. There is a fraction. So are we going to worry about focusing on the top of the fraction or the bottom of the fraction? Top, whichever one's ugly.
Okay.
So I'm going to present this question with Algebra 1 concept. If I give you x minus 3 and x plus 3, that's already factored from difference of 2 squares. Isn't that x squared minus 9? Okay. We got x squared by saying x times x. We got 9 by saying 3 times 3. And you're like, duh. I'm saying that for a reason. On the next example, I want you to write out square root of x plus 5 and square root of x minus 5. Let's apply the exact same rule. The way I got x squared was I took my first term and squared itself, correct? If I square this term, what do I get? X. If I square my second term, what do I get? Negative 25, so minus 25. Let's apply that on the ugly part with the radical here. So we're going to multiply by the clever form of 0, and before I do, I should have plugged it in. When I plug in the 0, we get 0 over 0. So yes, we're going to do more, but not factoring. So let's rewrite this problem. Limit as x approaches 0 of the radical of x plus 1 minus 1 all over x. So which part do we not like? Top or the bottom? Top. And I'm going to go ahead and make top look like the example that I just gave right here. The only difference is one has a plus, one has a minus. Right now I have a minus, so I need a plus.
Oh.
And this is, again, clever form of 1 because they're identical on the top and the bottom. I like parentheses, so I'm going to add them. So let's go ahead and write out limit as x approaches 0. Let's use that rule that we did. When I square this square root, doesn't the inside pop out? And then minus 1 all squared is still 1. So what I did right there was basically what was done on the bottom right here. So that made the top really easy. The bottom one, just like on the previous problem, I'm going to leave it alone. Yes, you can distribute. It could make your life miserable. Let's not do that. Does something eliminate on the top? Is there a, what's it called? Zero pair. Does that 1 and this -1 cancel?
Oh, yeah.
Yep. So we now have remaining the limit as x approaches a 0. Let's put the x in parentheses and leave the bottom as it is, because something will almost always cancel.
Okay.
What can I eliminate that is identical on the top and the bottom since it's multiplied as a chunk? The x's. So now can I plug in the 0? So I have the understood 1. 0 plus 1 inside the radical plus 1. That is going to give me 1 over what? 1 over 2.
How do you get 2?
0 plus 1 is 1, right? What is
Yeah.
square root of 1?
Oh, okay.
And then 1
okay,
plus
okay.
1 is 2.